Okay. So this is the ABR. So assuming this is area 0 and this is area 1. So what we're saying is that the ASBR summary LSAs are generated by the ABR. The purpose is to inform the backbone on how to reach the ASBR route. Okay, yeah. So you say the ASBR summary LSAs, they describe the routes to the ASBR and they're generated by the ABR, right? Yeah. Okay. Then we have type 5. So those are type 4. Type 4s and type 3s, these ones are generated by the same device, ABR. So type 3 is network summary. Type 4 is ASBR summary. Hope that is clear. Then type 5s are generated by they are known as AS external LSS. Now these ones are LSS that describe routes to the external network that are outside, or the external network that is outside the autonomous system. For instance, from that diagram, rather that topology, the ASBR, which is this device here, will describe how to get to this side of the network, the external network. Okay, so it will generate type 5. Okay, yeah, it will generate type 5, which we are calling them AS externals, autonomous system external LSS. I hope that is clear. Okay, yeah. Then we have lastly type 7. Type 7 LSS. These are LSS that describe routes to destinations outside the autonomous system. So they're kind of similar. Okay, yeah. So we refer to them as the no source stubby area, not no source stubby area LSAs. So they describe routes to destinations outside the AS. Now someone will be asking, but they seem to be similar with type 5. Because you have said type 5 and AS external LSAs, they describe routes to destinations outside the AS. Okay. Now the difference between these two guys, or that these two LSAs, is that, let me go back to that topology, is that these routes, you have a pointer. Now these routes, we have said we have looked at types. This guy produces type 7 and type 5. The ASBR will generate type 5 and type 7. And we have seen that the functions kind of are similar. They describe the routes to the external side of the network. Now, their difference is that type 7 are not allowed in the backbone area. This backbone area is area 0, this is area 1. These ones are not allowed there. It's like an abomination. Okay? Yeah. So they're only flooded within type 7 will only, type 7, let me point it correctly. Type 7 will only be flooded here in this area. It will be flooded here between this link. And for us to get these routes that are to the external side, to the backbone area, the type 7 LSS have to be converted to type 5. So when you're injecting these routes to this side through the ABR, this is the ABR, will be injecting type 5. So type 7 LSAs are not allowed in the backbone area. Okay, it's like exposing a network to an external protocol. Okay, so it's not allowed. It's a security measure. We do not allow type 7 in the backbone. So as the ABR is sending this type 7 to the backbone area, they are converted into type 5. I'll explain that clearly to everyone. Okay. So that is NSSA, LSA. Now, these ones are for IPv4 networks. Okay. These LSAs describe the OSPF version 2. Remember, we said you have two versions for OSPF. Version 2 as these kind of LSAs. We're going to look at OSPF version 3, which is ideal for, which is used with supplies IPv6 networks. Now, let's look at the problem of area subdivision. So if you have a single area designed for OSPF, this one will make it impossible to deploy some functions like route summarization. You cannot summarize routes. And also, it burdens the devices that they have to process large-sized LSDBs. Okay, so when the network is too large, the size of the LSDB increases, and it will overwhelm some of the low-end routers. Okay, so SPF requires that you have the area subdivision because it helps us to reduce the size of the routing table and also increase the device performance. Okay, yeah. So if you have so many routers in one network in one area, that means those routers are going to be impacted by large LSDB. And when they're impacted like that, it will deteriorate the performance of the equipment. So you have seen area partitioning that the different areas now are flagged LSAs within a given area. For instance, we have type 1 LSAs and type 2 LSAs. So these ones are flooded within a given area. Say the network LSAs are generated especially when the OSPF network is a broadcast. When the network is a broadcast is when we generate the type 2 LSAs. Okay, yeah, so these ones are only flooded within that given area, assuming we have area 1 here. So this router and this router, maybe they're using a broadcast OSPF network. So that means that one router will be elected as the DR and the other router will be elected as a backup designated router. Okay. Yeah. So in this case, we'll have router LSAs, which we say every router generates a router LSA, and the network LSA, which will be generated by the DR, will be flooded between these areas. Okay. Yeah. So this one helps to reduce the amount of flooding, or rather the amount of LSAs that are received in a router, because this router will only receive the LSS from this guy, and this one will receive the LSS from this one. Okay, unlike the situation where I've said you have so many routers in the same area. When you have so many routers in the same area, what happens is that you increase the size of the LSDB. So many LSS will need to be received. Okay. So we introduced the concept of ABR in order to process and connect two different areas. Okay, yeah. So the area partitioning comes with its own share of advantages. Okay, yeah. So how do we transmit inter-area? Inter, we have said, means different areas. Okay, so inter-area communication is usually performed by routers that sit at the edge of these areas, and we call these routers area border routers. So an area border router generates now the network summary LSA. Network summary LSA, we have said, is generated by the area border router. The reason is to assist in or the carrying information or other informing areas, different areas of the routes that have been discovered from other areas. In other words, it processes the inter-area routing information. So for instance, here we have router 2, which is an ABR, It will generate type 3 LSA, that is, it will generate the network summary LSA. So it will calculate the intra-area routes. Router 2 belongs to area 0, so it will calculate the intra. We have said intra is same area routes. So it will calculate the routes within this network based on the router LSS that are advertised and the network LSS that are flooded in that given area. And it will advertise these routes to other areas. So when advertising to other areas, we have said we use the network summary LSA. Okay. Now we talked of another concept known as virtual links. Virtual links came in to solve the problem where we have areas, remote areas, like we have area 2 here, which are not directly connected to the backbone area. So for us to connect a remote area to the backbone area through another area, you can see this is another area, we deploy what we call a virtual link. So configure a virtual peer between the ABRs, this ABR here, and this other ABR, okay? So on the first ABR, which is on router 2, you configure OSPF, then you specify the vlink-peer command, then you specify the IP address of this other peer, which is this IP address. Then on this router 3, you also do the same on your OSPF configuration. Then you say vlink-peer is 10.0.2.2, which is this IP address of that over there. So that way, it will be able now to establish this tunnel. We are calling it a tunnel. So a virtual link is a tunnel. It's a secure tunnel which enables a remote area to communicate with the backbone area. Okay, yeah, we call it virtual link. So a virtual link is established between two ABRs. But the two ABRs must have interfaces connected to the same NAN backbone. So these will be the rules. Connected to the same NAN backbone area. Okay. Yeah, note that the virtual link enables OSPF routers to communicate through NAN backbone areas, which may cause sometimes routing loops. So sometimes you might have a routing loop. So it's not the best. Don't use this method. It's not the best way to solve this. It can result into a routing loop here, where traffic is not leaving that area. So you use them with a lot of caution. Okay. So when you're setting up when you're designing your network, your OSPF network, is always advisable that you maintain the area 0 as the transit area. You maintain area 0 as your transit area. Okay. Yeah, maintain area 0 as a transit area, meaning connect all the areas to area 0. What does it mean by connect all the areas to area 0? All the routers should have, all the areas should have a router which has an interface that is connected to the backbone area. Okay. So we use virtual links with caution. Now we also introduced the concept of route importation. So we said we import routes, especially external routes that are coming from external protocols. We use the import command, the route import. So we can connect multiple autonomous systems together with the purpose of exchanging route information. Okay. Yeah. So assuming we have this route that has been advertised here, assuming it's a static route, which has been introduced on router 1. Okay. So to advertise this route to OSPF, we use this command, import -route. Then here you add static. For the case of static routes, use that command, import -route static. If it's from ISIS, you also say import -route ISIS. Okay, remember you're doing this on the OSPF process. We are doing this on the OSPF process. Let me show you practically. Trying to see whether we have a noise clip process on these guys. Let me start them. So as they're starting, let's continue explaining. All right, so we can have either static routes. You can specify static. You can also specify if it's a BGP route that you want to import. You can also import direct routes. What are direct routes? These are routes which are automatically discovered through the physical links that are connected to a given router or around a given router. If you have some old protocols like RIP, you can also import the routes from the RIP protocol, but RIP is not covered in this training, or at this level, we do not provide that information. So an ASBR is that router that is used now to LAN routes from an external protocol. So an ASBR flags external routes in an autonomous system, or using the autonomous system external LSA. This is type 5. Okay. Yeah. So type 5s are the only LSAs which are allowed in the backbone area. Type 7 are not allowed in the backbone area, and we are said we refer to type 7 as NSSA LSAs. Okay, not so stubby area LSAs. Now let's look at OSPF version 3 now. OSPF version 3. So we say OSPF version 2 is used on IPv4 networks. And OSPF version 3 is used on IPv6 networks, right? Yeah. So OSPF version 3 was mainly developed as a routing protocol independent of any specific network layer. I hope you can feel that improvement. So this is a protocol that was created to be independent of any specific network layers, right? Yeah. So it has a beautiful structure. Why? Because it takes advantage of the beautiful features that come with IPv6 addresses. So IPv6 addresses are meant to eliminate some of the issues with IPv4. So IPv4 addresses have a dependency on some other protocols. For instance, an IPv4 IP address has a dependency on address resolution protocol. It will require AR, address resolution protocol, when identifying the MAC address of a given host. But with IPv6, we don't need this. Okay? Yeah. With an IPv6 address, you can actually be able to identify the MAC address of a given host. Okay? So there's no need for dependency on her in IPv6. So IPv6 comes with very nice features. It has a very nice packet structure compared to IPv4. IPv4 packets cannot tell you, or rather cannot inform the network about the topology. They don't carry topology information. In other words, you cannot be able to see the structure of your network with an IPv4 packet. But an IPv6 packet, you can actually see the entire topology. Okay, yeah, because IPv6 comes in with the neighbor discovery protocols. So IPv6 comes with an inbuilt neighbor discovery protocol, which helps you to map out an entire network topology. Okay, yeah. Allow me to control some noise that is around here. All right. Yeah. So we're going to look at more features of IPv6. Sorry, and also of OSPF version 3. Okay. So another thing about OSPF version 2 and version 3 is that they are not compatible. Okay. They are not compatible. Okay. Yeah. So you'll have to use, if you're defining OSPF configurations, you'll have to configure an OSPF version 2 and an OSPF version 3 on the same router. It's possible to have OSPF version 2 and OSPF version 3 on the same router. Okay. Yeah. Yeah. So they are not compatible. You have to define each independent. All right. Let's look at similarities of OSPF version 2 and OSPF version 3. So the similarity is that we have area division in both. We can subdivide the network into different areas. And both OSPF version 3 and version 2 define the same router types. Okay. Yeah. So we have terms like designated router, backup designated router, we have internal router, we have autonomous system border router, we have the area border router, right? So those router types apply to both. Another thing about the two is that they affect route calculation based on the route preference and the cost of the route. Okay. Another thing about us, the two, is that they support the same similar network types. We have broadcast and broadcast multi-access. We have point-to-point, and then we have point-to-multi-point network. Another thing that is similar is the types of packets. We have the LO packets on both, database description packets on both, link state requests, link state updates.